good evening, students. Welcome to Pre-Calculus at Home. Hopefully you're sitting in a comfortable seat and have gotten some rest to watch and learn for the next about 20 to 30 minutes. So today we are going to be focusing on the topic of exponents and polynomial operations. So that's what we'll go right here. Exponents and polynomial operations. Go ahead and put the class period that you're in. I'll say this is first right now. Okay. All of this should be review. So a monomial is a constant, variable, or product of numbers and variables. A mono means one, so we're looking at something with one piece to it. So an example of a monomial would be just a number like -6. Another example would be 7x. We call that an expression when we add a letter to it. And another example would be 1/2 x squared y. Some students may be confused. Why is this considered a monomial if I've got two letters? When we have two letters, if there's not a plus or a minus in between, it is still a monomial, okay? All of these are examples of monomials. We use exponent rules to simplify monomial expressions. So the product rule. The product rule tells us that if we have x to the power of a times x to the power of b, it equals x to the a plus b. So I understand there's a lot of letters to explain the rule, but it's really not as confusing as you think. All it's telling you is that when you are multiplying monomials, we add our exponents. So over here we'll have an example with actual numbers. So if I had x to the 8th times x to the 7th, this would become x to the, add your exponents, 15. Next would be the power rule. The power rule looks like this. X to the power of a raised to the power of b. So we have a power raised to another power. In this rule, what we do with our exponents is we multiply them. So we have a times b. Multiply the exponents. So an example would be the letter y raised to the power of 6 and then raised again to the power of 2. We have a power raised to another power, so what we're going to do is multiply them. This is going to become y to the 12th. Quotient rule. Quotient means divide. So that would be x to the power of a over x to the power of b. For the quotient rule, what we do with our exponents is subtract. So x to the a minus b. So an example here, if you had b to the 5th over b squared. This is a quotient, so therefore we need to subtract our exponents. So 5 minus 2, this becomes b to the 3rd. Okay, the negative exponent rule. So if I had x to the power of -a, this is kind of like the flipping rule. So what happens is that this negative exponent will flip and go to the bottom. If you didn't already know this, this right here, and you can actually write this up. This is meant for any notes that you want to write yourself. So x to the -a really has a 1 at the bottom, an invisible 1. You just have to know that. Hopefully you already knew that. So in this case, when we have a negative a right here, what we're going to do is we're going to move this whole piece down to the bottom. When you move it to the bottom, it makes it positive. So therefore, this becomes 1 over x to the power of a. So you're probably confused as to what the heck, why is there a 1 now at the top? Well, we now have a x to the power of a. Well, even though we moved it and there's nothing left up here, there's still that invisible 1 at the top. It doesn't just disappear. Okay. So an example would be p to the negative 2. P to the negative 2 would simplify to, move it down below, 1 over p squared. All right, the zero exponent rule, anything raised to the 0 power is 1. I like to use the example of like a Christmas tree. This is my Christmas tree. Raised to the 0 power is going to be 1. It doesn't matter what it is, anything raised to the 0 power is going to be 1. So if I had 4x to the 5th raised to the 0 power, doesn't matter what's inside of this whole thing is raised to 0, so this is going to simplify to 1. Okay, so we're going to move on to the examples at the bottom. So at the top it gives you a little bit of a hint, just in case you make a small mistake somewhere. When adding or subtracting monomials, make sure you combine like terms. Okay, so let's start with what we know what to do here. So negative 6 to the 4th, we can use a calculator. Let me go get mine real quick. I don't know, negative 6. Okay. Notice that here the negative is not inside the parentheses, so the negative is just going to go straight down. That negative is still going to be on the outside. So we got 6 raised to the 4th power, literally just typed it right in, and it gives me 1,296. All right? And it's being multiplied to negative 1/4 raised to the 2nd power. So for this one, you have to remember there are invisible 1s in here. This one has a exponent of 1. This 4 has an exponent of 1. So what we're going to end up doing, we have a power raised to another power. You look at your notes, the power to power rule, we're supposed to multiply our exponents. So this is going to become negative 1 to the second power, good. And then 4 to the second power. I should have put that negative down here. Oh well. So now we've got negative 1,296 times negative 1 squared is just going to be a negative 1. And then 4 squared is 16. Once again, you can use your calculator. So negative 1,296 times negative 1 over 16. Is this good? Okay, so that it would look like this on a calculator. Hit enter and you get 81. That will be your answer here. All right, moving on to the next one. So we have multiple rules in here. First, let's deal with the power raised to another power rule. We are supposed to multiply. I like to go like this to show that I'm multiplying.
On the left one?
Did it stop?